Right, we have another example. Right, so we have a circuit diagram. Part of it is similar to the one we had before, but now we want to have a look at working the following out. It says, using this circuit diagram, calculate the values of A, B, and C that make T true. So, because we've been given some bits and pieces along the way, we've been given P and Q and S as well as T, this gives us a bit of a head start. Right, so really what it amounts to is we need to draw up a truth table for this entire circuit using what we've learned. Alright, so there's the truth table over there. Right, we begin by filling in our truth table. Remember, start at the last input that you got, which in this case is going to be C. So, and the pattern, remember, goes 0, 1, 0, 1, 0, 1, just move the table up a bit, and 0, 1. And notice we've got 1, 2, 3, 4, 5, 6, 7, 8 inputs because there are 2 times 2 times 2, or 2 to the power 3 possible permutations. Right, next column up, remember, double the pattern, so 0, 0, 1, 1, 0, 0, 1, 1, and finally 0, 0, 0, 0, doubling the pattern yet again, so 2 zeros becomes 4 zeros, and within a number of 4 ones. Right, that's all the possible inputs. Right, reiterating what we've done on a previous example, P is the output of A and B. Notice an AND gate because it's a flat tail and a rounded nose. Short circuit Boolean evaluation for A and B means I'm hunting for zeros, so all 4 of those inputs over there are 0 when A is being used as an input, and therefore that allows me to conclude, because I'm ANDing it, that automatically the corresponding rows must be 0 for the output P as well. I now apply the same argument, the same line of thinking, to column B. So B being an input to P over here, when B happens to be 0, then automatically using short circuit Boolean evaluation, I can also conclude that P must be 0 for those inputs, which leads me to only carefully check the last 2 rows, which is 1 and a 1 is, yep, that's a 1 by definition, and a 1 and a 1 is 1 by definition, because we only get a 1 out for an AND when all the inputs are 1s. Okay, I've moved the table down a bit to look at the diagram. Q is the product, or the AND, of P and C. So, we apply the same principle. Right, so using the same principle, short circuit Boolean evaluation, all these inputs over here for P are 0, meaning that Q must be 0 for those inputs as well. If I times or multiply or AND, if you like, anything with a 0, I get a 0 out. That leads me to just safely check the values of P and C. Right, now this value of C happens to be 0 as an input, which means I must be getting 0 as an output, which only leaves the last row with C being equal to 1 when P is equal to 1 at the same time. So C1 and P1 gives me a 1 out as a result. So we now have the truth table completed up to and including column the output for Q. Right, we now have to calculate S. And what's going on over here? Well, Q is going into S, and this is a NOT gate. It's a triangle with a little bowl on it. So that means all that's going to happen now is that the output of Q is going to be negated or flipped over. So all the 1s become 0s. Wherever I have a 1 in column Q, I turn that into a 1 for column S. And wherever I have a 0 for column Q, I turn that into a 1. So that is the result for S. This finally brings us to working out T. Right, T, however, is not an AND gate. T is an OR gate. I know it's an OR because it has a rounded tail and a pointy nose. So remember, the symbol for OR is actually addition, which kind of means if I have a 0 anywhere, sorry, if I have a 1 anyway, I'm going to get a 1 out. That is the Boolean short circuit definition. If I have a 1 anywhere as an input, I get a 1 out. Right, so what are the inputs to the output for this gate T? Well, one of the inputs is S, which means if I look at my truth table, wherever S is 1, T is going to give me a 1 out. Interesting. All that we have to check now is what happens when the values of C change. Alright, so I've worked out every permutation. All that's left over is what happens with C, which is now 1, or S. But hello, the value of C is a 1. Applying the same Boolean short circuit definition, I get a 1 out. So the answer to this question is, right, okay. The truth table has told me no matter what the inputs are, the output value for C is a 1. So if I go back to answer the original question, calculate what values A, B, and C make T true. The answer is any value of A, B, and C will result in T being true. And I know that because I've proved it using what is known as perfect induction or a truth table.